for the ride a little bit. Last class, what we did is we defined tangent. And we defined tangent as sine over cosine. And you guys said that's the same as y over x. Do we agree with that? Now what I'm going to do is I'm going to make my unit circle. I'm going to put my quadrantal points. So there's my points. All right. So at 0 degrees, right? So I'm just going to go to 0 degrees on my chart. At 0 degrees, I want to know the value of tangent, right? So what did we say? We said that tangent is equal to the y value divided by the x value, right? Guys, what is 0? What is 0 divided by 1? 0 divided by 1 is 0, isn't it? Okay. So at 0 degrees, we got 0. How about when I go to 90 degrees? How about when I go to 90 degrees? When I go to 90 degrees, what do I have? I have 1 divided by 0. What's 1 divided by 0? Undefined. Undefined. So what I want you guys to do at 90 degrees is to put a U. All right. At 180, what do I have now? I have 0 divided by -1. What's 0 divided by -1? 0. If I go to 270, I have -1 divided by 0. Undefined. 360 is the same as what? 0. What if do you guys see a pattern here? Yeah, so if you were to guess, so it goes 0, undefined, 0, undefined, 0. What would you guys guess this is going to be? Undefined. And what do you guess this one's going to be? And then undefined, and then 0. What does undefined mean? What does undefined mean? It means you can't be that, right? It means it doesn't work, right? It means it's bad math, right? So what we're going to do is we're going to have vertical asymptotes. I'm going to show you guys what that is in the picture in a minute ago. But this is where tangent of 0 equals undefined. We have vertical asymptotes. All right, let me go to my graph. Let's put those. Where are those vertical asymptotes? At -90. So watch how I'm going to write that. I'm going to write these like these. These are going to be dotted lines. And I want you to think of, I made them red for a reason. They're boundaries, okay? So there's one there. There was one at -3 pi over 2. There was one at 90. And there was one at +3 pi over 2. All right, so I got these boundaries, right? I made them red. There you have it. Now, what is the next piece? Well, I have these values of 0. Where are those values at 0? At -360, at -pi, at 0, at pi, and at 2 pi. What about the rest of these? What about the rest of these values? All right. What do you notice about these values? It's kind of strange why I selected these. What are they all? 45, 135, 225, 315. What are those values? Well, if I was to plot those really quickly, you don't have to draw this. Where's 45 put me? Right here, right? Where does 135 put me? Puts me right here. But what would be the reference angle of 135? What'd you say? Well, yeah, I'd have to go to 180. So what's the reference angle? 180. Reference angle. 45. Good. Thank you. Okay. How about if I go to 225? Now I'm over here, right? What's my reference angle at 225? It's also what? It's also 45. And how about if I go to 315? What's my reference angle at 315? It's 45, right? So I gave you all reference angles of 45. Anybody want to venture a guess why? Well, do you guys agree that this is my ratio? And dude, you're right on your game, man. Because what is the ratio for tangent? Isn't the ratio for tangent opposite over adjacent? What's radical 2 divided by 2 over radical 2 divided by 2? What's anything divided by itself? 1. Yeah. So guess what? These are all 1. Now here's the question we got to figure out. Are these, so let's put 1s in all these. Now we got to figure out if these 1s are going to be positives or negatives. Okay? Because what do I know? Depending on the quadrant, some are positive and some are negative, right? So in what quadrants, guys? In which quadrants is tangent positive? Is it positive in quadrant 1? Yes. Is it positive in quadrant 2? No. Is it positive in quadrant 3? Yes. Is it positive in quadrant 4? No. So in quadrant 1 and 3, tangent is positive. In quadrant 1 and 3, tangent is positive. In the other quadrants, it's what? Negative. And so this one is going to be negative, positive, negative, and positive. So Jameson, here's what we're going to do. We're going to take these negative 1s and positive 1s, and we're going to put them on our graph. And when we do that, it's going to wind up looking like this. All right. How do I play connect the dots with this? Because you all agree I got to play connect the dots, right? How do I play connect the dots? If I have these what? What did I call these things? These red things. I call them asymptotes. I also call them what? Boundaries. Boundaries meaning what? Things I can't cross. So how do I play connect the dots? Well, it's going to look like this. This is going to be really weird, guys. Watch. I'm going to connect the dots. I'm going to come towards this boundary. And then I'm going to come towards this boundary, but I can't what? Can't cross it. And then I got the same thing here, right? And then I got this piece, and then I got this piece, and then I got this piece. So what do you notice about a tangent curve? Well, there's a couple of things really, really important about a tangent curve. If I give you a sine curve, what's the lowest point on a sine curve? -1. What's the highest point? 1. Is that true here? Is that true here? No, because what's at the end of these connect the dots? Arrows, meaning that what? This keeps going up, right? And what does this do? This keeps going down. So what do we notice? We notice that the range is very different, isn't it? Okay. Notice something else. Really important, guys. Really important. How many cycles do you see? Well, this is a cycle, right? And that's a cycle, and that's a cycle. So I see 3 cycles, and then I see a half a cycle and a half a cycle, right? How many total cycles do I see? 4. How big is a cycle of tangent? Starts at pi over 2, ends at 3 pi over 2. How big is that? How big is that? How big is it from pi over 2 to 3 pi over 2? Pi over 2 to 3 pi over 2 is 3? Oh, 2. What's pi over 2 the same as? Degrees. 90. What's 3 pi over 2 the same as? 2. 270. What's 270 minus 90? 180. Yeah. So what we actually get here, guys, is tangent has a shorter period length. Okay. That's exactly what we're going to do. That's exactly what we're going to do. So we're going to answer some questions about what we just did in that picture. So first of all, the domain. The domain's weird. Guys, is every possible value of x allowed in tangent? No, because we had some undefineds, didn't we? So the domain, I'm going to write this really weird, is going to be all reals with the exception that x cannot be. All reals with the exception that x cannot be. I'm going to write it weird. Ready? Dot, dot, dot. Negative 270, negative 90, positive 90, 270, dot, dot, dot. So what does that mean, the way I wrote that? It's kind of weird, isn't it? It's kind of weird. What it means is the following. It means that I can have any number except this pattern. So the dot, dot, dot means you have to keep going to get the other ones, right? Yeah. By the way, what's the gap between each of these? Negative 90 to 90 has a gap that's how big? 180. So where would the next one be? Be 180 forward or 180 backwards, right? Okay, what's the range? You said that you can go as high as you want and as low as you want. So would you agree it is this? All reals. What are the roots? What are the zeros? The roots are where it crosses, right? So the roots happened at negative 360. Oh, hang on. Don't write that. So the roots are dot, 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 negative 360, negative 180, 0, 180, 360, dot, dot, dot. Does this graph have any maxes or mins? No. Don't worry about H. We're not going to answer H. We will answer this one, though. And Jaylani said it. She said that it is a period length of pi or 180 degrees. And last piece, guys, this is what's called an odd function because it has symmetry to the origin. This is an odd function because it has symmetry to the origin. All right. Cross out 56. We're not going to do 56 right now either. Okay. All right. So it seems like we have a lot left. Believe it or not, guys, we are not going to learn anything new whatsoever. Not at all. Promise you. Not at all. Notice something about this, guys. Secant is paired up with which function? See how they are set as a relationship. What is the relationship? Secant equals 1 over cosine. Cosecant equals 1 over sine. Cotangent equals 1 over tangent. So guess what I just did? And you guys don't even realize it. I just threw 3 more trig functions at you. So guess what? Sine, cosine, and tangent are not the only ones. There's 3 more. Secant, cosecant, and cotangent. So Jaylani is shaking her head like, you got to be kidding me. We got to do 3 more of these things? Absolutely not. Because I told you guys a second ago that I wasn't going to show you what? Anything new. And I'm not. Secant goes with which function? The first one, cosine, right? So let's pretend this says cosine of 60 degrees. Okay, let's just pretend. If I asked you guys to give me the value of that, what would you do? Well, if you've been following along at home, you would do this. Any disagreement? All right. What is my radius? Well, my radius is right here, isn't it? It's a 60-degree triangle, right? So what's across from the 60? Radical 3/2. And how about the other side? 1/2. So if I asked everybody to label this point, what would this point be labeled as? 1/2, comma, radical 3/2. Now, which of those values is cosine, the x or the y? It's the x, right? So does that mean that cosine of 60 equals 1/2? It sure does, right? It sure does. So I know you're all holding your breath for that great big moment where I make everything confusing, right? Don't do it. Read that first thing at the very, very top of the page. The reciprocal trig function. So guess what? Secant of 60 degrees equals 2/1. Because these are called what kind of functions? Reciprocal functions. So what did I just do? I flipped the answer. It's literally that easy. What about the one that's on top? What do you mean the one on top? Oh, well, that's what we just did. So here's what Jaylani just said. Jaylani just said, well, there's the formula, 1 over cosine of 60. Why aren't I just doing that? Because, Jaylani, wouldn't that be 1 divided by 1/2? Which would be keep it, change it, flip it. 2. So doing 1 over cosine is the same thing as what? Taking the reciprocal. As I promised you guys, not new, is it? Right? Not new at all. Cotangent of 150. Cotangent of 150. There's even an easier way for this one. Guys, what is my value for tangent? It's y over x, right? Anybody want to venture a guess what cotangent's going to be? X over y. Because it's what kind of a function? The reciprocal function. So I'm going to find, there's 2 ways to think about it. I'm either just going to find x over y, or I'm going to what? I'm going to change this to be tangent, get the answer, and then what? Flip it, which is going to do the exact same thing, right? Yeah, so let's find tangent of 150. Oh. Maybe while we're out, I can figure out how to draw circles. I can practice that. 150. Reference angle, everybody, is 30. All right. Let's go ahead and label our one half and our 1 and our radical 3/2. So guys, at this point, if I asked you for tangent, you would say it's equal to y over x. Well, what's the point? The point is, give me that point with signs, guys. Somebody in the other class stayed after. And she's like, I don't understand how you get this point. I can write this picture. I just don't get how you label the point. I said, kiddo, let's pretend like this is the coordinate plane, right? Let's pretend like there's a grid on this. You're going from 0, 0 to this point. How do you get to this point? You slide to the left. How much? This much. You go up. How much? However much this side is, right? So I'm going to the left, radical 3 over 2. And I'm going up 1/2. Okay. Now I'm going to write down the tangent solution, and then we'll write down the cotangent solution. So this tangent solution would be what? The y value over the x value. Now, could I simplify that right now and feel great about myself? Could I simplify that, make it look nicer? Yeah, but why would I do that? Because my next step is to take this and what? Flip it. So I might as well do that at the end of the problem, right? So cotangent of 150 equals that, right? Which is just the flip of that. If I did a keep it, change it, flip it, and rationalized it, I would wind up with a really simple answer of this. Yeah, this would be the simplified answer. This would be what I would get if I took all this and did a keep, change, flip. Good? And the last one we're going to do for today is, oh, sorry, did everybody get that? Good? Last one we're going to do for today is this. This kind of just takes everything into one. So what would you do first to solve this one? Turn it into something in terms of degrees. I know you like working degrees better. Cosecant of 135. So I want to find sine of 135. Where does 135 put me? Here. Unit circle time. Got to find this point. Reference angle is 45. So what are my two sides? Radical 2 over 2 and radical 2 over 2, right? How do I get to that crucial point? I go to the left. And I go up. And which of those values do I want? The x or the y? Why the y value? Because I'm dealing with sine. So sine of 135 is equal to positive radical 2 over 2, right? So is that what I wanted though? No, I wanted cosecant of 3 pi over 4, which is 2 over radical 2. Would I leave it like that? No, I would what? Rationalize it, which would give me 2 radical 2 over 2. Or radical 2. Jelani? Basically, you just flip them. Hence the phrase,